All right, so you've got a big tech interview on the horizon. I can pretty much guarantee you're going to get asked about Retrieval-Augmented Generation, RAG. So this is our session to make sure you absolutely nail every single one of those questions. Ready? Let's get into it. Okay, so here's how we're going to do this. We're going to treat it just like a real interview. I'm going to throw a common question at you, give you a second to think, and then we'll break down the perfect answer together. Everything we talk about will be right here on the screen to make it super clear. Sound good?
So, first things first, we gotta start with the fundamentals, right? At its heart, RAG is all about feeding a language model the exact information it needs to answer a question. But how does that actually happen under the hood?
This is a super common opener. And what the interviewer is really checking here is, do you get the basic plumbing of a RAG system? Like, how does the information get from point A, our database, to point B, the model? And you know what? The answer is so simple, it's almost surprising. We literally just take the relevant bits of information, that's the context, and we stick them right inside the prompt we're sending to the language model. That's it. It's not some kind of black magic. The model gets the user's question and all the evidence it needs, all in one neat little package. And this is what that package actually looks like. It's broken down into 3 parts. First, you've got the system instruction. Think of this as laying down the law for the model. Then you have the context injection. That's the raw text we just talked about. And finally, the user's actual question. Keeping these 3 things separate and in this order, that is absolutely crucial for getting a reliable answer.
And there's a really important term for this whole process. It's called context grounding, and it's exactly what it sounds like. You're grounding the model in the facts you gave it. You're telling it, hey, don't just go off and make stuff up from your training data. The whole point of grounding is to make sure the answers are factual and come only from our documents.
Okay, so injecting context sounds easy enough, but this is where a lot of people trip up, and it leads to a classic interview question. What happens when you go overboard and give the model way too much information? The term you need to remember is context stuffing. You have to know this one. It is the polar opposite of giving the model clean, useful info. Instead, you're just drowning it in data, and trust me, it can totally wreck your RAG system. So let's break down why it's so dangerous. I love this analogy. Think about it like an open book exam. If you give a student 3 perfectly organized, super relevant pages of notes, that's perfect. That's a good RAG system. But context stuffing, that's like throwing 50 random pages from 5 different textbooks onto their desk. Suddenly, more information isn't helpful, it's just noise. And the model, just like that poor student, is going to get really confused.
And that confusion, it creates a cascade of problems. 4 big ones, really. Number 1, it obviously confuses the model. Number 2, a confused model is way more likely to hallucinate, just start making stuff up. Number 3, you can actually blow past the model's token limit, which means important info might get chopped off. And number 4, and this is a big one, more tokens always means more cost and higher latency. So context stuffing isn't just bad for quality, it's expensive and slow.
All right, so we know context stuffing is a huge problem, and we know we need to keep the model grounded. So the next logical question is, how do we actually do that? How do we build the right guardrails to force the model to stay on the straight and narrow? And this right here, this is the million-dollar question. This is what separates a basic understanding from a deep one. Your interviewer wants to know if you can think defensively. How do you actually prevent the model from dipping into its own massive brain and force it to use only the facts you've provided? Well, the secret, believe it or not, goes right back to that open book exam analogy. You wouldn't just hand the student the notes and hope for the best, right? No. You'd give them really clear, really strict instructions. You tell them exactly how to use those notes. It's the same with the model. You don't hope it does the right thing. You design the prompt so it has no other choice. And here are the 6 most important strategies for doing that. First off, you need strong, explicit instructions in your prompt, like we just talked about. Second, the prompt needs a proper, clean structure. Third, and this is huge, remember quality over quantity. Don't stuff the context. Fourth, you can tune the model's temperature setting down low to make it less random and creative. Fifth, a great trick is to ask for citations. That forces it to point to the evidence. And finally, number 6, and maybe the most important, none of this works if your retrieval is bad to begin with. It's the old saying, garbage in, garbage out. Okay, let's level up a bit. Let's talk about a more advanced and, honestly, a more realistic scenario. What happens when your retrieval system does its job perfectly, but the documents it finds actually contradict each other. This happens all the time in the real world, right? You've got old policy documents, different versions of a file.
Now, this is a tough one. An interviewer asking this is trying to see if you've actually built these things in the wild, because a production-ready RAG system has to be able to handle this. So what happens when the ground truth you're feeding the model isn't so true after all?
Okay, let's make this super concrete. Imagine your system pulls up two different document chunks about your company's refund policy. Chunk 1 says refunds are allowed within 30 days, but Chunk 2, probably from an older file, says refunds are allowed within 14 days. Now the LLM is staring at two conflicting facts. It has absolutely no idea which one is the right one. And when a model gets confused by contradictions, its behavior gets, well, chaotic. It becomes completely unpredictable. It might just pick one at random, or it might try to smash them together and say something weird like refunds are allowed for 14 to 30 days. Or, and this is the really dangerous part, it might just confidently hallucinate a brand new answer that sounds reasonable but is totally made up. At that point, your output is basically a lottery. So what's the fix? Well, the best fix, obviously, is prevention. Clean your data. Get rid of the old stuff. But okay, in the real world, that's not always possible. So you've got other tools. You can use metadata, like dates, to filter and only retrieve the newest documents. You can use a re-ranker model to prioritize more authoritative sources. Or, and this is a clever one, you can actually tell the model in the prompt to point out the contradiction instead of resolving it. Because an honest, I found conflicting information is way better than a confident lie. And that really brings us to maybe the single most important takeaway from all of this. Please, whatever you do, avoid weak, vague prompts. A prompt that just says, answer the question based on the context, that's not an order, it's a polite suggestion. And these models don't do well with suggestions. You have to be explicit, you have to be direct. The reliability of your entire RAG system really boils down to how clear your instructions are. Because in the end, it really all comes down to this one question. Are you building a reliable expert? Or are you building a confident guesser? And the difference between the two? Well, it's in all the details we just covered. It's about providing clean context, building strong guardrails, and being smart about how you handle ambiguity. Get those right, and you'll be in great shape.